well, good afternoon, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? How'd it go yesterday with the sugar rush? Some of you? No? Not much sugar? Okay, good. Did some of you give out candy or went to get candy? Anyone? Yeah? Let's go. Yeah, we gave out baggies of chocolate and some baggies of flaming hot Cheetos. Let's go. You should have seen the people that went. They were like, also the Cheetos? I'm like, yes. They're just Cheetos, you know. Anyways, warm-up number 41 is on the screen. Let's get started, please. That shouldn't take you more than 1 minute. Or, my bad, I'm saying like you got a fat minute, I guess. All right, share with your neighbor what you got for the warm-up, please, so I can get someone to help me out. Go. All right, mean, JC.
7.
7. Hands if you got 7. Median, Eric. Hands if you got 7. Mode, Pedro. No mode. All right. Q1, Amy. What is it? 3.5. Hands if you got that. Looks about right. Q2, Zach. 7. And Q3, Andrew. 7.5? 10.5. Hands if you got that. All right. And of course we got 2 and we got 12. Hands if you got something like that. Yes? All right. All right. Agenda for today, copy this. Warm-up number 41. We're still measures of variation. Today we're going to add a couple more things to what we are doing. And I'm pretty sure it's not going to be a big surprise to you guys since we've been on this ride already for 5 years. Can you believe that? 5 years. Right? You guys know me, right? That I give you guys first the hard stuff and then a lot of work. Then I give you guys the shortcuts afterwards, right? All right, so today we're going to be looking at shortcuts. So like that, we don't do as much work as we've been doing now with measures of variance, okay, or variation. So tonight's home plate page 143, and you're going to do number 6 again. You already did it, but we're going to do it again, but with today's shortcuts, okay? All right. We good? All right, so yesterday went well. Home plate for today, get your Cornell note ready. You don't need a prayer model. So our objective for today, I can summarize and compute the measures of variation. We've been working on this already for a bit, right? All right, and we don't need a prayer model because we already have it. But remind your neighbor, what are the 3 measures of variation, please? 3 measures of variation. Yeah, range. What else? Variance and a variance standard deviation. Yes. Non-examples, I put the measures of central tendency. Once again, all 3, and all 3. Okay. Now, I'm going to add a couple more things to the formula. So by now, we should have the formula for variance and the formula for standard deviation, right? All right. Double check to make sure you have those. If not, write them down because we're about to tweak them a little bit. Write those down, please. Now, mind you, these are formulas for the variance and the standard deviation, but of what? Talk it over to your neighbor. Of what? Population or sample? Population or sample. It's either one or the other. What do you guys think? Population or sample? All right? And if you don't know, ask Samuel. I think he knows. You got it. All right? So, those are variance and standard deviation for what, Jet? Yes. That is correct, for population. Population. Okay. So, how does it change for sample? Let's see. The first thing that's going to change, look up. What do you guys notice, obviously, that changed? The symbol. Instead of being just a symbol, the Greek letter psi, we actually use the letter S for sample. Okay? There's another thing that changes. Tell your neighbor, what would this change to? What would that change to? Talk it with your neighbor, see if they remember, what does that change to? Jet, pass someone. Who? Lowercase n, so far so good, yes, so far so good. But this part right here, Aaron, pass someone for this part right there. X bar, that is correct. Write that in there, please. X bar. So with that said, write your formula for the standard deviation for the sample. And once again, this second one is for the what? Sample. Sample. Okay? You're like, makes sense? Yes, it makes sense. So these top ones are for the population. This is for the sample. So then it would be S equals square root sum of X minus X bar squared over low cap N. Okay. So that would be obviously true. Does that make sense? Yes? Yeah. Except for, pay attention to this part, sometimes whenever you get data from a population and then they ask you to find the standard deviation and the variance now for the sample, sometimes it doesn't make sense to use the same formula to do the same thing for the sample, because now the sample might have a smaller amount of population and it's going to create a little error on the standard deviation and the variance. So look at what I'm going to do to change it just a tiny bit. Look up to the screen. That's the only thing that changes for the sample. Why? Once again, because once you go to a smaller sample and find the standard deviation variance, sometimes it creates an error, and the number for the sample, many times it's almost overlapping the mean of the population. That's why they do that little change. Okay? Any questions so far? No? We good? All right. So with that said, turn your paper over. Without looking at your notes, write me variance, standard deviation for the population, variance, and standard deviation for the sample. Without looking at your notes, let's see if you got it. Use some time. All right, there it is. Double check your work. Hands if you got it on your own the first time. Yeah, some of us. Yes, good. Yeah. All right. Turn to your neighbor and give them a high five if they got it. Yeah. All right. All right. So with that said, check this out. Look at this problem. Look up. It says, example Q. The number of public school teacher strikes in Pennsylvania for a random sample of school year is shown. And once again, pay attention to the wording. Here it goes. The number of public school teacher strikes in Pennsylvania for a random sample of school years is shown. Find the sample variance and the sample standard deviation. So tell your neighbor which formula you're going to use for that. Which formula are you going to use for that? All right. Okay, Mel, go. Give us a formula. Sigma. Oh, my bad. Sigma like the sum, my bad. Uh-huh. Hands if you agree with that. Tell your neighbor why we're going to use that one. Tell your neighbor why we're going to use that one. Yeah, because it says here a random sample. So from this point forward, guys, whenever I give you a problem, and even though the work is the same, but if you write the wrong formula, I'm going to dock you some points. Tell your neighbor what I just said, please. Isn't it the same work pretty much? It's the same work, but the formula is different. So that's the only thing that we want to make sure that as we go throughout the school year, because the rest of the school year, guys, we're just going to keep adding formulas that are like maybe computational formulas, but you need to know the difference between being a population or a sample formula, okay? So with that said, copy these numbers down, please. Example Q, and I want you to find me the variance, and I want you to find me the standard deviation for that sample, please. I'll give you some time. Go. Okay, just in case we need some direction, we start with a column of the items, which are these, yes? I like to put them in order, 3, 7, 8, 9, 10, 14. Yes? You see 3, 6, 3, 6, yeah? Then from there we find the mean. Yeah? 8.5? 8.5, hands if you got the mean. Yeah? And then from there, we go to the next column, which is x minus the x bar, which is 3, 7, 8, 9, 10, 14, minus, then we're going to subtract from the mean. Which means the next column is taking that difference and squaring it, yeah? So the difference for that one was negative 5.5, negative 1.5, negative 0.5, 0.5, 1.5, and 5.5. So far so good, yes? Oh, my bad. That goes till the end. Then the next thing is that. Oh. N minus 1. Yeah. All right, so then we take that squared. What is 5.5 squared? What is it? 30.25. About 1.5 squared? 2.25? 0.25? 0.25? 2.25? And 30.25. Yes? Then if you add all that together, divided by n minus 1, which is divided by how many numbers? 6 minus 1 is 5. So you're going to add all this and divide by 5. Who's got the sum of this? 65.5? Yeah, 65.5. And that gives us, what is it? 13.1 approximately, okay. And that's our variance, right? That was s squared. Oh, let me write it over here, sorry. S squared. All right, and the last step, we need to take the square root to find standard deviation. Who's got square root of 13.1? Mel? What is it? 3.62. 3.62. And did you got something like that? Yeah? All right. So, our variance, 13.1, and our standard deviation, approximately 3.62, and this is for our sample. Yeah? All right. Now, I think we got the process down. Is that correct? From 1 to 5, show me how comfortable are you with the process for standard deviation. 5, 5, 5, 5, 5, 3.5, okay? All right. So by now we got this because we've been doing this from the beginning of the school year. Well, today I'm going to give you a formula where you don't have to do all this work. It's a shortcut formula. So write this down, please. Ready? These are known as shortcut formulas for variance and standard deviation for samples. We got this one for the variance and this one for the standard deviation. And then we'll go through it so we know all the components. Copy that really quick. So let's see. Now, what's the difference between this one? Let me highlight it. And that. Look at it. Okay. We know that x is the value, right? The value that goes on the first column. Okay. So this is something with a squared outside. Talk it over to your neighbor. What's the difference from one to the other? What's the difference from one to the other? Okay, let's start with this one. What does this mean? What does this mean? It means we have the sum of what? All the items, right? Okay? So right before we do the mean, which is divide by the number of items, it's the sum of all the items. Okay? So what is this? Let's see, who went last? I pick Jet. What does this mean? This one. Yeah, each item squared, and then you add them, and that's this right here. That's the only difference from one to the other. And we know that n is the number of items in the sample, and here is the number of items in the sample times the number of items minus 1. Okay? And at the end, the square root. So I'm going to leave that up here, and we're going to do that problem that we just did with all the work, but now using this shortcut to find out how fast we go with that one. All right, here we go. So keep that on the side. Write these numbers again. Write example super cute. We're going to now use the formula for the shortcut. All right, so we're going to use for the variance, we got n times the sum of each item squared minus the sum of each item, and then we square that over the number of items times the number of items minus 1. Okay, let's start with this one. I'm going to use green for that part. All right, so I'm going to write, all right, go. Who's got it? Jet, pass someone? Okay, so 9 plus 10 plus 3. 19 plus 3 is plus 8 plus 14 plus 7. All right, so we got that. Next, I'm going to change to pink. Let's do this part. And I'll use red over here. We got the sum of x squared. All right, so let's start here. What is 9 squared? 81 plus 10 squared. 100 plus 14 squared. Damn. Plus 7 squared. Plus and plus 9. Okay, who's got the sum of that? Five what? 509. Hands that got 509. Double check, please. I need a second hand. $4.99. Okay. All right. So now that we have that, check this out. We do the following. All right. So here we go. We start with this one right here, which is what? $4.99. What goes here? 51. What goes right here? 6. It's a number of items. 1, 2, 3, 4, 5, 6. And down here is 6 times what? Yeah, which is 5. Okay. S squared is 6 times 499 minus 51 squared. Who's got 51 squared really quick? 601. And then 30. Last but not least, let's see. 6 times 499, that's 2,994. Yeah? Let's go. Let's go. Divided by 30. So we got, is it 393? Am I good? Yeah? Divided by 30. That's approximately what? And this is squared. 393 divided by 30. 13.1? What did we get earlier when we did the whole work? 13.1. Woo! Let's go! Let's go. So this shortcut formula allows us to avoid like a bunch of work that we did prior with going decimal, decimal, squared, squared, one by one, just by plugging in these two values from the beginning. Yeah? And of course, if you take the square root of 13.1, that gives us what? For the standard deviation? 3.62. From 1 to 5, how comfortable are you using the shortcut formula? Yeah, it's just plugging in stuff, right? Yeah? Jet, you all right? You want some coffee? No? Okay, good. Yeah? Okay. And pretty much that's it, guys. For today, I'm only going to give you that much because I don't want to get you right here. Here's whelmed. I don't want to get you here. So we're going one step at a time. So for tonight, number 6, you're going to do using the shortcut formula. Number 6, remember, number 6 was the one that had A, B, and C. There were 3 different ones. So basically, find the standard deviation and variance for all 3, compare them, but use the shortcut formula. Okay? We'll stop right there. We good? All right.